All right, everyone, welcome to day 2 of determining or understanding velocity acceleration, the physics behind the derivatives. So today what we're going to do is an extension of what we did in the last class, which remember in the last class, we looked at graphs and we determined what's happening in velocity, speed, acceleration in terms of positives, negatives, increasing, decreasing. So today what we're going to do is look at actual functions, the algebraic functions. And then we're going to determine specifically just what is the velocity acceleration at certain points in time of those functions, and then also seeing how that looks on a graph. So we're going to kind of connect what we have been doing with derivatives algebraically and then what we did with the graphs on last class. So here's the title for your notes, and then we will start with an example. So we're going to do 2 examples. So the first one, our function, we're going to have S of t is our function. So t stands for time, because remember, it basically deals with kind of seconds. So our first function is going to be 1/3 x to the third minus 4x plus 20. Okay, so there's going to be a series of 4 different questions that I'm going to ask and that we're going to answer based on these 2 examples that I have. And then we're going to be drawing a graph to go with them. So the first question that I have is going to be, what is the velocity at 0? So when time is 0. And so in this example, we should ask ourselves anyway, no matter what, is if they're asking for velocity, what is velocity in terms of? Velocity, remember, is not in terms of the original function. This is called the positional function because this is where it originally starts in its position. So the velocity, remember, is the velocity function, which is the first derivative. So in order to even answer this question, if you see the word velocity, we're going to have the derivative, the first derivative. So we're going to take the derivative. It'll be s prime t, or the derivative of s at t. And so if I do my rules, I'll multiply 3 times a third, which cancels out to be 1, and then subtract 1 from the exponent. So x squared minus 4, and the derivative of 2 is just 0. So here is my velocity function now. So in order to answer this question, I need to find the velocity function. So now when is the velocity at 0? So now this is where I'm going to set it equal to 0, and I'm going to solve for x. So there's different ways that we could do this based on what you remember. We could do a simple solve here because there's no x in the middle, no bx in the middle. We could just add 4 to both sides. And then we'd have x squared equals 4, and then take the square root, as long as we remember that when we take the square root of something like this, when we're solving for x, that we have 2 solutions of both the positive and the negative 2. Now, other people might have been saying in their head, like, wait a minute, I can factor that pretty easily. And yes, you could. So you could have factored it as x plus 2 and x minus 2, which will give you the same answers when you set those equal to 0 as x equals 2 and negative 2. So either way, you could either factor or you could just solve for x in this case. So now we have 2 points at which the velocity is 0. So let's put that on a number line. So we're going to draw that on a number line, like a horizontal number line, because that's what we're working on, is horizontal motion. And so we know right now that we have points. So I'm just going to be very broad and very vague here. So we know that -2 and 2, that our velocity is 0. So I'm going to put big points there because remember, what does this mean? Like when the velocity is 0, what was happening with our object? Hopefully you remember that when the points crossed this axis, it meant that they changed directions. So that means somewhere over here in this range, we don't know. The direction could have been a negative. It could have been a positive. We don't know. Same thing between -2 and 2. We are now going to find out what is happening in between 2 and -2. And then the same rate, we're going to find out what is happening above 2. So what is happening to my particle or my car or my object, whatever it is, what is the direction of the velocity in those different intervals? So we're not going to worry about necessarily if there is a constant speed yet. We're not going to worry about anything other than what is the direction of the velocity. So that's going to be part 2 of this. So once part A, we found the velocity was 0 and we plotted those 0 points on the graph. So now step 2 is we're going to find out when is text box. So here, part 2 is when or how is the particle, or you can say object, changing directions. So we just want to know in those intervals I just stated, because there's 3 intervals technically on this graph. There's time is less than -2, time is between -2 and 3, and then time is greater than 2. So 3 intervals, we need to test what's going on. So how do we test that? Well, it's similar if you remember the intermediate value theorem, how when you had an interval, you just had to pick a number that was between those two and then determine if it was a solution or not, or if it was positive or negative, and you could tell if it was a number or if it was a solution. So what we're going to do here is we want to pick a number that's to the left of -2, and we're going to test it in the velocity function. So we can pick anything less than -2. Let's go with -3. Okay, so we're going to check out -3. So you're going to put in S prime of -3. So basically the derivative function at -3, which is -3 squared minus 4. So that'll be 9 minus 4, which is 5. So all we're worried about here is not actually what the velocity is, but the direction of the velocity, and it's positive. So if it's positive velocity, hopefully you're saying to yourself, that means it's moving forward, or it's up, or it's to the right. So our particle is coming down from here to this point because it's a positive. So all the numbers right now to the left of -2 should be positive. Anything that I plug in, so it's coming down from this direction. So we don't know, it could be doing this. We don't know right now, we're not concerned. All we're concerned about is the direction. It is positive right now to -2. Now we need to test between -2 and 2. So let's go simple. Let's go with a 0. So if I find the derivative, the value of the derivative at 0, I'll have 0 squared minus 4, which is -4. Okay, so that means if my velocity is negative, that means that at -2, when it came to a quick stop, it changed directions and now it's going negative. So now it's coming down here between -2 and 2, and it's negative. So some point in between -2 and 2, we don't know when it changed direction yet, but we know that it's negative. Okay, because anywhere between there, I could plug in a 1. If I do 1 squared minus 4 is going to be -3. So anything between -2 and 2 is being negative velocity, which means that it's under the graph. All right, now let's test the +2. So a +2, we need to go above 2. So let's just go with 3 while we're on this pattern here. So 3 squared minus 4 is going to give me the same thing that I had for -3 squared. That's going to give me 5. So that means that up here, it's going in the positive direction now because velocity is positive. So this is kind of what's happening. Again, we don't know. It could have a bunch of things happening here. We don't know. We're not concerned. We just know that what's happening to the left of -2 is it's a positive velocity. We know that between -2 and 2 is a negative velocity, and above 2 is a positive velocity. And that's all we're trying to represent on the graph right now. You can represent it however you want. Okay, next question is now we are going to determine the acceleration. So now question C will be, when is the acceleration 0? So hopefully you're thinking to yourself, it's acceleration. So if it's acceleration, then I need to figure out the second derivative in order to figure out what an acceleration could be. So I'm going to take the derivative of this guy here, the derivative of my velocity. So the derivative of the velocity will be 2 primes, so S prime prime t. Okay, so this is the acceleration function. It is a function. And then the derivative of that would be 2x. So now if I want to know when the acceleration is 0, I'm going to set it equal to 0 and solve for x. So that's going to give me x equals 0. So that means at this point at 0, okay, probably is where the vertex is So maybe this is happening. You would have changed directions here because my acceleration would have stopped right there and I would have decelerated. It could have been a parabola. Okay, so my acceleration is at 0. So I'm just going to plot that so I understand in my head what is happening when the acceleration is 0. All right, then the last question we're going to throw in, because I talked about this a little bit in class, was the jerk. So we're going to talk about what the jerk is. So D would be, when does the object jerk? And so in this case, remember the derivative, or the jerk is the third derivative. So I would take S, and now it's prime, 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 T. And so the derivative of the acceleration function, which is right here. So the derivative of 2x is just 2. So the object jerks at 2. So at this point right here, we have some sort of little jerk or jolt action in our object. Okay, so just so you can understand on the graph what is happening at each one of these points. All right, we're going to do one more example, one that's a little interesting, take it to the next level that you might encounter. So let me go to a new page here. All right, so next question, we're going to do example number 2, is we're going to do the function S of t, okay, positional function, and we're going to go 1/4 x to the 4th minus 8/3 x to the 3rd plus 6x squared, right, minus 10. Okay, and now we're going to go over each of the questions that we just went through and talk about what's going to happen with this function. Notice as well, this function has a higher degree. The one we just did was a cubic function. It only went to the 3rd power to start. This one is a quartic function. It starts with a 4. So it's going to be a little bit different. We might have to bring back some old methods that we have done previously in other math classes. So let's start with the first question, which I'm not going to retype this for you, so you can write it down, or you can just reference the last question we did. So the first question is, when is the velocity 0? When is the velocity 0? So if you remember, velocity function is what we need to start with. We can't know what the velocity is if we don't have the function. So we need to take the derivative of this guy. So multiply 4 times a 4th, that cancels, weird, lovely. And we're ending up with x to the 3rd as our first term. Minus, now here, multiply the 3 times 8, that's 24. 24 divided by 3 gives you 8. So negative 8x squared. And then 2 times 6 gives me 12, so plus 12x. And there is no derivative of negative 10, or it's just 0. Now we want to set this equal to 0 and solve. All right, so first of all, oh, forgot my x here, 12x. First of all, this is not a quadratic, it's a cubic. So we can't do the methods that we thought for factoring as far as what we just did, difference of 2 terms. We can't set it equal to 0. So what I would do is think of, this is going to be a combination. So you're gonna have to think of other things that we've done. So hopefully the first thing that you always want to check when you have to solve is maybe, can you take something out? Can you take out a GCF? So if you look here, they have an X in common. So I'm going to start by taking an X out and see what happens. So look for a GCF as one of your tools to solve these equations when they ask you to solve for 0. So if I take an X out, I'm now left with a quadratic. So now what I've done is I've made it easier for myself, taken out an X, and now this is leaving me with a quadratic, one that I can do what multiplies to be 12 and adds to be negative 8. So hopefully in your heads, you're thinking, oh, well, multiplies to be 12, 6 and 2, and that adds up, right? So 6 times 2 gives me 12. And then 6, oh, I need to be negative though. So it'll be x minus 2 and x minus 6. Okay, so now my answers here. So I'll have x equals 2 and x equals 6. And then don't forget that this x on the outside is actually a solution. This x is equal to 0 still. So you should have 3 solutions. So don't forget, that if you have a cubic, whatever your degree is how many solutions you could potentially have. So since it's a cubic, it means that you could have 3 solutions, and we do. We have 0, 2, and 6 as our solutions. So let's put that on a graph to start with. All right, so we have x equals 0, 2, again, it's going to be very bare minimum, and 6. Okay, so 0, 2, and 6. So this is where potentially things are changing. Well, it does change. The velocity is 0 at these points, which means it's either stopped or changing direction at these points. So now we have 1, 2, 3, 4 different intervals that we now need to test to see what is happening to the velocity at that point. So that is our question number 2, or question B, is how and when is the particle changing direction? So what is happening with the velocity at these points? So let's pick something less than 0. So we'll pick a -1, and we have to plug it into this function here, into the velocity function. Okay, so s of -1, you'll have s prime of -1, I'm sorry. So it'll be -1 to the 3rd power. Make sure that's in parentheses, even though it doesn't matter for the 3rd power, minus 8 times -1 squared, plus 12 times -1. Okay, so if you plug that in there, you're going to get, this will be -1, and then this will be plus 8, and then minus 12. Okay, and that's going to give you a -5. So velocity is negative. It really doesn't matter what the number is over here, right? But we're concerned that it's a negative. So it's negative, which means that it's under the graph or coming from this direction as it's approaching the time of 0. All right, we got to keep going now. So we need to test something between 0 and 2. So let's go with 1. Okay, so s prime of 1, okay, equals 1 to the 3rd minus 8 times 1 squared. Being a little lazy with this, but that's okay. Plus 12 times 1, because it's positive. It's a lot easier. So 1 minus 8 plus 12 gives me a +5 this time, because 1 minus 8 is -7, plus 12 gives me the +5. So that means between 0 and 2, there's something happening here. So you could curve it, you could draw it like this. Doesn't really matter as long as it's up here. You can be as fun and creative as you want with it. All right, now we need to test the next interval between 2 and 6. So let's just go with 3. Why not? So s prime 3, all right, will be 3 cubed, which is 27, minus 8 times 3 squared, plus 36. Okay, and when I did this, I got a -27. So between 2 and 6, you're going to have a negative velocity, which means that it's going under the graph. Okay, again, we don't know how or why or what's happening over there, so we can draw it however we want. All right, and then last thing we need to test is what is happening above 6. So let's just go ahead and test 7. And I'll tell you right now, it's a pretty big number because it's not, because s to the 3rd is pretty big, or sorry, 7 to the 3rd is pretty big. So 7 to the 3rd, and then minus 8 times 7 squared, plus 12 times 7. Okay, so 7 cubed is going to give me 343, and then subtract 8 times 7 squared will give me -49, but then I need to add on 12 times 7, which gives me 835. So we're back into the positive range over here. Okay, so this is what your function would look like in the way that it's going. All right, last, or not last, we got 2 more questions. So question C is going to be when is your acceleration 0? Okay. So remember, acceleration, we have to find the derivative of the derivative, or the second derivative. So that is going to give me 3x squared minus 16x plus 12. Okay, so now this is a Smurf problem. Looking at it, the quadratic. So we need to find numbers that multiply. So we have to do 3 times 12. That gives us 36. So two numbers that multiply to be 36, but then add to be negative 16. Okay, so let's take a minute to think about that. Okay, we got 6 times 6. 6 times 6. When I add together, though, that gives me 12. I could do 3 and 12. But when I add those together, I get 15. I could do 4 and 9. If I add those together, I get 13. What else could I do? 36. That doesn't work. 36 divided by 2, I could do 2 and 18. But the problem is this has to be positive. So if I do 2 and 18, one of them has to be negative. 2 plus negative 18 is negative 16, but then 2 times negative 18 gives me negative 36. So it's not going to work. So guess what? This one is not factorable. So anyone remember any other method to solve quadratics other than factoring? Let's bring this old bad boy out. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. Woo-hoo. The quadratic formula can get us any x that we want. We could have done the quadratic formula over here instead of factoring. Any quadratic you can do and you'll still get those same answers. So we're going to have to use the quadratic formula because we cannot factor this. Okay, so just remember 3 is your a, b is negative 16, and c is 12. Let's plug it in and see what happens. Okay, so negative b would be negative 16. So it'll be 16 plus or minus the square root of b squared. So that'll be negative 16 squared minus 4 times 3 times 12. So times a times c. All over 2 times a, which is 2 times 3 or 6. So in case you forget what you need to do, you need to get this number inside the radical down to one number. So we have 16 plus or minus the square root of, if we do all this in here, we're going to end up with a negative 48 over 6. Okay, now before we move any further, let's just think of our logic here with numbers. I have a negative under the square root. What does that mean? It means that it's imaginary. So what this means is that our acceleration is never 0 in this case. So it's never at a constant speed or never at a stop. So there is no point in which acceleration is 0. We'll be dealing with this a little bit more in WinRM, but for right now, because it's a negative number, we can stop and we can just say, oh, acceleration is imaginary right now. So that means that there is no point in which x is going to be 0 or it stalls or it stops in the acceleration. It's always either increasing or decreasing in this particular function. All right, last but not least, let's get to our last question of the jerk. So last question, jerk. So when does the object jerk? So now we need to find the derivative of the derivative. So we're finding the derivative of the acceleration function. So s prime 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 of t. And that would give me 6x minus 16. Okay, so then what you can do is set it equal to 0 and solve to find out when it jerks. Add the 16 over and divide by 6. So if I add the 16 over and I divide by 6, I'm going to get 2 2/3 or 2 2/3. So at that moment in time, about 2 2/3, so probably like right about here is when your object has jerked. Okay. All right, that's it now. Hopefully you will have the tools to be able to finish your assignment, your homework assignment for today. Let me know if you have any questions.